So there's 2C from the worksheet from last night. I feel like I didn't give you a satisfactory answer. Maybe a satisfactory answer, but not a satisfactory explanation.
Yeah.
Yeah, that's fair.
So we just found the area.
Mm-hmm.
Everything from 0 to 3, not to 4.
Right.
So why are we adding 3?
Because when we do the integral of the derivative, we get back to the original, but there's limits involved. So top one minus bottom one.
Okay.
Another way to say that is this more relates to that warm up with the melted snow. If you integrate a rate, you get the change, the amount of change. So when we integrated this melted snow, this is like how much snow melted, the change. I don't know how much snow there is or was. I know it changed by that much. So I know that F changed by pi minus 2. And it changed from 0 to 4, so I plugged those in to figure out exactly what F of 4 was. Is that reasonably better?
Yes. Because I want to do cube.
Other questions from that worksheet?
Number 4.
Okay, and which one?
For what C, I've seen numbers 5 and 6. I don't remember why, but
Okay. Complete the following table. So this is the area from -1 to x, where we're just kind of gradually increasing. So did you get capital F of 4?
yeah,
What was that?
7.
So if I want to get from 4 to 5, then I just need to add this extra rectangle. Does that make sense?
I just thought
I'm just sort of adding on here. And I'm short-circuiting this work based on what you've already done.
so you're kind of like making up a shape because like there's nothing actually under 5.
Well, I think the graph is right here. Is that the problem? You couldn't tell that the graph is down there at -3?
No.
There you go.
Don't see that.
Sorry. There's a little dot there, but you're right. That's weak. So that's -3. So that would be subtracting 3. And then to get to 6, that would be a -3. So we would subtract 3 more, assuming your 7 is right. Again, this sort of relates to what we were just talking about. I definitely know this change from 4 to 5 is -3, and from 5 to 6 is -3. So if your 7 is right, then the 4 is right. I guess I could say it's F of 7. Nope, it's F of 4 minus 3. This one's F of 5 minus 3. So I definitely know it changes by 3. But your only concern was you didn't see the line. Carson, number 4. Points of inflection of F. Justify your answer. Justify first. So POI of capital F would be where F double prime changes signs. Okay, let's see. So I need F prime first. Well, F prime is the derivative of an integral. So that's going to be 3 times x squared minus x squared squared. And then all of that times 2x. Yuck. And if that's all we wanted, we would safe stop that, but we want a second derivative, and we'll probably have to do some algebra with it, so I think I need to clean that up. So 3x squared minus x to the 4th times 2x. So that's 6x cubed minus 2x to the 5th. That's f prime, capital F prime. I want the second derivative for points of inflection purposes. So 18x squared minus 10x to the fourth. I want to set that equal to 0 to figure out where it changes signs. So I'm going to factor out a 2x squared. That would leave 9 minus 5x squared. So x equals 0 as a double root. I remember that at double root things don't change signs. So I don't know if it's positive or negative on either side of 0, but it's not changing signs there because it's a double root. The other one, let's see if we set that equal to 0, 5x squared equals 9. So x equals the square root of 9/5 plus or minus. And that's not a double root. So it will change signs there. So those are my points of inflection because second derivative changes signs at those two spots. That's kind of an ugly problem because of the algebra in there. Good question though. Test outline? Why not?